Hello, everyone. I've started the recording, so I think we can start.
Hello, everyone. Can you hear me clearly? Okay. So, John, why don't we do this in kind of an interview style? You can ask me whatever you want, and I will provide any feedback, notation, documentation.
Sure, that sounds really great. So this meeting came about from a Slack conversation about the shared NFS server that we have for production, and specifically about running GitLab on GKE, how that's possible when we have, well, we think that we need some of these shared file systems on GitLab. And the file systems I'm referring to here are the ones that the temporary storage that we use for LFS, uploads, artifacts, and CI builds. And typically, like before we had direct upload for object storage, we needed these file systems mounted across the front of the backend fleet so that Sidekick had access to files that Rails would write. We have yet to remove these mounts, and after discussing this in the the distribution channel, it was thought that maybe we have some of these mounts when they aren't necessary. I know that the directories are used, but they may not be necessary to be, like, they may not need to be shared between the front and the back end fleet. That's when Jason, it's when he volunteered to do a quick presentation or a quick discussion about his own findings with regard to these directories, specifically around using Kubernetes and GitLab on GKE, and whether or not we need these mounts. So, sorry, that was kind of a bit of a background statement, but I guess the first question is, going through these directories, which ones are you certain that we don't need to have shared between the front and the back end fleet?
Actually, you don't need to have anything mounted between Sidekick and Unicorn at all, except where Pages comes into play. And they're working on that, but it's a current drawback right now. Noting that currently our Helm charts very specifically state we don't support Pages because of the requirement for the shared storage between the two items, as well as some of the interesting things you have to do in regards to putting the front end proxy in front of it. That's the reason we don't support it right now. When it comes to shared file storage that you need at any point, the only one that's actually required, we intentionally actually keep within the same pod. Workhorse and Unicorn still have certain behaviors that are literally, Workhorse reads it in, writes it to a file, and then tells Unicorn, hey, use this file. It's on the file system. So until we get all of those removed, we've actually put Workhorse in one container, Unicorn in another container, but attached them with a shared mount. So it's the same file system in a single instance, but mounted to two containers within the same pod. You can think of it like one folder on a host system that's not shared over NFS, but then having two containers in Docker both mount that directory. That way it's safe for those two to be able to share because the mount and file system itself is being handled by the host, except that's not then shared through NFS to every single node. Now, because we pair Workhorse and Unicorn directly together, Workhorse will actually talk only to its local Unicorn. It won't talk to any other Unicorn out there. So we don't have to worry about having that shared directory across the entire fleet because only those two are going to talk about local file systems. Now, there is a drawback in that out of the box, this is currently done with a tempfs that's on that machine. If for whatever reason that node runs out of temporary disk allotment, you will see a problem. There are ways to make this a more persistent disk. However, we still are very wary of creating a persistent shared disk.
Great. I think direct upload is turned off by default in the omnibus. I was just writing this as a note in the agenda. Without direct upload, I assume we do need to have a shared file system between the front end and the back end,
Yes,
right?
that is
Okay.
quite true. And that is
Is there a reason why that is turned off by default? Is there any reason why, like if you have object storage enabled, it seems like you'd want to turn that on?
um, so there's a few aspects of that one, and I'll say that in the charts that is not only on by default, it's forcibly set to true, because we don't want these containers to ever have to talk to each other directly. That's kind of the idea. In the omnibus, you need to understand that it's a nature of the evolution of those behaviors. There are going to be a number of people who don't want to use object storage. Will this setting come into play for them? No. But perhaps there are people that have traditional architectures that are on their way to migrating to that point. Maybe they're not quite ready yet. We can't force that option on them. So while that would make things more straightforward, it doesn't necessarily make sense in single instance. Like if you have one single omnibus node, it doesn't necessarily make sense that you need to set it or don't need to set it. And if we change that behavior at some point, while it was not actually ready in some versions of GitLab, then you would actually have a problem. You don't want to have that kind of experience for the user. When it comes to a larger, more distributed node system like we have, there's no reason that we can't do it at this point. But it's one of those things where we had to evaluate that we're not going to have a massive impact on every single person we default this flag true for. Plus, if you have an existing behavior and it works without having direct upload, do I magically change the entire data handling patterns for you? Or do I tell you you need to set this flag? So it's one of those, where's the best place to enable this by default? Can we enable it by default? And what's the impact on the user experience, both from configuration and management?
Okay, yeah, I think that answers my question. Thanks. So I have another question for you as someone who is one of the people that are more familiar with running GitLab on GKE and Kubernetes. I think I know of a couple issues, but I'm curious to hear from you. What issues do you foresee if GitLab were to start using our Helm charts? GitLab.com wanted to use our Helm charts and run the front end in Kubernetes on GKE. What do you foresee as potentially some issues that you would have, or that we would have at scale?
Honestly, I don't immediately see any. One of the biggest hold-offs from running the front end right now on that, which trust me, I would love to do, is still that binding between Pages and Unicorn Workhorse. That's annoying at this point. Well, I guess technically I should be saying Sidekick and not Unicorn Workhorse. Am I correct, DJ?
For Pages, I'm not actually sure.
Oh, okay.
So Pages basically like for most of user side key. And technically we should not have to use, I think, that on the Unicorn, but today there are definitely some code paths that for the checking if you have Pages enabled, they use Unicorn. Sorry, they need shared storage, but it's not like hard to really like remove the dependency from the Unicorn. It's harder to remove that from the side key.
Okay, so that actually assuages some of my concerns when it comes to Unicorn itself. Because when you guys say front end, my brain goes Workhorse and Unicorn, and how do we put it there? One of the other slight differences that I see that's not anything that's a performance impact, is more a monitoring and the way you're laying things out kind of impact, is right now we deploy the Nginx, right? The Nginx ingress, because this is the Kubernetes standard. However, there is Trafic, there is a JProxy, so we would want to evaluate if there's a different one that we want to use. And this comes into play because of routing based on path, right? So if you want to have a certain portion of the fleet that's API and a certain portion of the fleet that's HTTPS SSH, and et cetera, et cetera. There may be some work that we haven't fully explored in how to configure sections like that. But as long as all the nodes have the ability to reach the assets they need, in other words, they can get to the object storage buckets, they can get to the Redis services, and they can get to the Postgres services, then there's nothing that prevents Unicorn and Workhorse from operating completely independently from the rest of the application suite, other than the one known caveat about pages.
I think in that thread on distribution, Marion noted that we might have some trouble with uploads because there needs to be room on the pod for there must be enough temporary storage room on the pod. Could you elaborate on that a bit?
Okay, so that comes back somewhat to what I said earlier in regards to how those two share a tempfs, right? Now, I'm going to double check real quick here. I have the template open and I'm just reading it real quick. I believe, yeah, the shared upload directory, I should say, that is defined as an empty dir, which means it will be created as a tempfs on the node on which the pod runs. So the pod contains the two containers, and then Kubernetes creates a tempfs and then mounts that to both containers as a part of the pod. If your node runs out of disk space for that tempfs, you will have a problem. Now, currently, there's no way to override that value without an alteration to the chart, and I have no qualms about giving you guys a way to configure that, because I can fully understand that at our scale, we may run into issues where somebody tries to upload a 5 gig package, because it happens.
So it's a way how Race is right now configured. If you use direct upload, it is configured to perform a dual storage write. It means that it tries to use some temporary storage in the target NFS. And on the other hand, it performs a direct upload to remote storage. Technically, it means that if we would basically disable on the right side upload to local storage, I mean locally mounted storage, you never really store that in the temp. It always would go directly to S3 or GCEs. So you don't really need to keep very big temps at all. I think that the only requirement would be the uploads, but the uploads by definition, I think they are 20 megs of size. Artifacts, LFS, packages, what else would be there? They could basically be written directly to the object storage without having to buy that on the temp.
Not all the packages come. The npm packages goes to they're ignored at workers level, so they end up in directly to Rails, and I don't know if they are uploaded later by Sidekick or if they are uploaded in some other way. But workers knows nothing about the npm packages, so can't direct upload them.
Because I think that npm can be handled via legacy uploads infrastructure, right? And then we may be really we are moving that to the persistent storage of the packages. Something along that lines. But I think npm by definition, they are way smaller. I think the biggest concern, I think that from Jarv here is artifacts, which they can be 101 gig. LFS objects, which are by definition a few hundred megs very often. So this should be fine.
Right, and the existing mounts that are done for this are shared upload and shared artifact because of that physical requirement. So we do still have tempfs in place for that sharing of the two. As I said, we can work to have an actual disk. It would be still ephemeral. In other words, because we'd be running in GCE or GKE, we would get an ephemeral disk from GCP and attach it to the pods. And as long as it's all inside the same pod, it's okay. It's when you start sharing across multiple pods, possibly different nodes, that's when read write many comes into play. But anything that we can do to remove the requirement of a physical disk, please feel free.
So it sounds like what I'm hearing here is that these directories that I've listed, and I realize this is sort of the omnibus view into a GitLab deployment, and not everyone will be familiar how these directories map, but it sounds like for all these directories we have mounted, we don't really need to mount any of them. And that as long as Workhorse and Rails are deployed together, which they are across GitLab.com, we could just remove all of these mounts today and we would be fine.
As far as I know, I mean, I'd love to test that theory first,
Of course.
but as far as I know, you're correct.
In the case of the builds directory, I don't remember if we've done this already. Do we already default to live tracing being on? Because we do that in the charts, but I'm not sure if we've done that in Omnibus yet.
I have no idea. We would have to talk to Sinia. I think that there was some like 1 or 2 small bugs left with the live traces, but it's already running for ages on GitLab.com. So it should be a matter, I think, of the changing default to use live traces, because live traces are then archived to object storage as regular artifacts, and we do need like the temporary storage on the disk as part of the sidekey job to basically read and concatenate all chunks and then upload the single file. Technically, our build traces today, they are Atmos 4 max, unless you configure the runner to be higher. But unfortunately, I prepared a change on the GitLab runner that it plays nicely with GitLab to send 100 even. So we have to be prepared that in some cases, this kind of temporary storage for the side key, it can be quite big because of the intermediate operations that we do. We would not store data, but like there may be some required space where we download data from object storage to much easier manipulation locally, not remotely.
Right, and a certain amount of scratch disk is not that hard to provide. You just have the trick to remember is that the way the cloud native architectures work is as long as you're within the same pod, I can do whatever you want. When you start going to multiple copies of that pod, now I have to deal with shared storage. Now
like for this temporary storage, it doesn't have to be shared. It has to be shared only between Workhorse and like Unicorn, but it doesn't have to be shared across different pods. The only tricky part with that is I don't think that we have any cleanup procedure because we assume happy that this is shared storage with almost unlimited space. So if you would start having to use like something like temp, I would say that like we have to fix the problem of like recycling that storage, because like technically we can do anything in the unicorn, but we will not do anything in the unicorn if like the unicorn dies for whatever reason, because it gets killed halfway and we're not gonna touch that file later. So I would say that like the cleanup process should be out of the bounds, running likely as a side container or something like that on the cloud native if we gonna have this temporary storage.
Yeah, garbage collection should be done. Now, with that being said, the nature of the way these things work, if you are using an actual scratch disk instead of a tempfs, if the pod itself is relocated or drained, then that ephemeral storage will go away and it will be purged.
Yes, and it is great. I think this is desired.
Okay, so are we fairly satisfied on which do need, which we don't need, and also I think we need a little bit of investigation, or at least confirmation in documentation, of exactly which features we're using out of the box inside the charts and which ones are actively being used in production for comparison.
Yeah, I think we can. I think the next steps for this is going to be to try to. I think we should probably move. You can configure the shared directory in Omnibus. So for GitLab.com, what we can do is point it to a different mount point and use local disk, and that way we can keep the size, like keep it. We can have a larger disk for shared on each node, or at least have it under control. So if it fills up, it doesn't, cause problems. And then we can do that on staging. And then if it looks good there, then the next step would be to do it on Canary and see how it goes there, and then production. It sounds like this is something we can do fairly easily, and it'll probably, we've had a lot of incidents recently with the shared NFS server causing performance issues, and it's the last remaining NFS mount we have, other than Pages, of course, but Pages isn't going away. So it'd be really nice if we can remove it.
So, John, I think you may be interested about the Pages, because if you would have like the hybrid architecture for Pages, that like you run the sidekey for Pages jobs like separately outside, you could basically have like the Pages contained on one or two nodes only, with these Pages mount only there, not really anywhere else.
Yeah,
maybe it would work that way.
It's not that much overhead, because obviously like nothing else is writing to Pages except the Pages fleet and Sidekick. So maybe, but yeah, that's actually a good point. We can also isolate the Pages NFS mounts to 2 fleets of machines, which would be really nice. And then, and this will just make it easier for us to scale, scale the fleet and
with one exception. Project destroy worker needs to also be executed on this pool of servers.
Mm-hmm. Yeah.
Because destroy will also remove Pages.
Yeah.
But I think that these are only 2 exceptions.
Yeah. Okay. I think that's it, everyone. Thank you very much. And we'll end the call. Bye.